previous video, we learned about the recurrent neural network. So now we will implement the recurrent neural network for solving a sentiment analysis problem. Now you can see these are some basic imports, but this time you will see a new type of layer, which is the simple RNN layer. Apart from that, you will also see LST and GRU bidirectional, but don't worry, we have to learn them. We are yet to learn these layers, so don't worry about them. But yeah, this time we are using the simple RNN layer. Now we will read the data. This is the same data that we have already worked on. So we have the reviews, and for all the reviews, we have a specific label associated with them. 0 means negative sentiment and 1 means positive sentiment. Now, after that, guys, I will not dive into these things because these are already done. So we have done some visualization, visualizing the positive reviews, visualizing the negative reviews. After that, we will split the data into feature and target and then train and test. Then we will go through all the pre-processing step, which is tokenization. Then after tokenization, we'll put the tokens in the sequence. Then we will check the max length, the length at 99% quantile. Then we will perform padding, pad sequence. Okay. So this is the final training data, and we will perform the same steps on the testing data as well. So we have already done this, right, while solving sentiment analysis. Now the change comes here in the neural network. So this is where our model starts. So we have the embedding layer, right? This time we have eliminated the flatten layer, and rather than using the flatten layer, we are actually using a simple RNN layer. So you add a simple RNN layer. Now you might be wondering, what is this 64? So guys, this 64 is not the number of units. Number of units is automatically decided by the length of the document. So what is the max length of the document? The max length is 45. So there will be 45 RNN units. Okay, 45 such RNN units. It totally depends on the length of the documents. So now the question is, what exactly is this 64 here? So let me tell you, this 64 is this number of neurons in every single RNN unit. Okay, number of neurons present in a single RNN unit. That is this 64. All right. And then after that, we have the dense layers. Okay, we will call the compile function, we will call the fit function, and we can see how much score we get. So we are running this for 11 epoch. And after 11th epoch, we can call predict function and we can check the classification report. And it seems like the score is very poor, right? It's only 58, there's only 58% accuracy. So very poor score. So obviously there should be some way of improvising this model. Definitely there are. So we will see that in the next video.